When we talk about inheritance in Python, we usually talk about some child class receiving attributes and methods from some parent class. And the convenient thing about inheritance is that in the child class, we can override attributes and add even more methods without any effect on the parent class. As always, I think it's easiest to demonstrate all of this using a simple example. Let's assume for a moment that we're looking at a university with a diverse body of students, and some of these students are exchange students from other universities. So let's go ahead and create the class student. And this class is not going to do anything for the moment, so we're going to write pass underneath. In addition to this class, we're also going to create the class exchange student, which inherits from the class student. And equally, this class is not going to do anything for the moment, so we're also going to write pass underneath. Even though both of these classes don't do anything at the moment, we can already make instances of both of these classes. To create an instance of the student class, we can write student_1 equals student. And similarly, if we want to create an instance of the child class exchange student, we can write exchange student1 is equal to exchange student. If we now go ahead and print student1 and subsequently print exchange student1, we will see in the console output that we have a student object and an exchange student object that we've created. By doing this, we've already created an instance of the parent class student, as well as an instance of the child class exchange student. Let's move on and create some attributes for the student class. Let's say that our student has a first name, a last name, and perhaps a major. So we can create a constructor with an init method, which takes as parameters the first name, the last name, and the major. And subsequently, below that, we can write self.firstName is equal to the first name, self.lastName is equal to the last name, and self.major is equal to the student's major. So now, in the student object that we've created below the classes, we can pass in a first name, such as Peter, a last name, such as Parker, and a major such as history. And you won't be surprised that we can actually access these individual attributes as well. So if I, for example, print student1.firstName, you can see that in the console output, it will show me the first name of the student. And let me show you that this also works for the other attributes. So if I create this print statement for the last name, and also for the student's major, and run this again, you will see that these individual attributes are displayed in the console output. But now let's move to the child class exchange student, because it gets more interesting here. Since the child class exchange student inherits from the student class, I can also go ahead and add the attributes first name, last name, and major to the exchange student object. So let me give the exchange student the first name Evan, the last name Hill, and the major biology. I can now also access these individual attributes by printing out exchange student1.firstName, exchange student1.lastName, and exchange student1.major. But at the moment, we're not really making any use of the child class exchange student. One way that we could make use of it is by adding an attribute that is not in the parent class. And one attribute that the exchange student should have, but a regular student shouldn't, is a home university, because after all, the exchange student comes from a different university somewhere abroad. So what we need to do in this case is we need to create an init method in the exchange student class, and this init method takes as parameters the first name, the last name, the major, and the home university. But the first name, the last name, and the major are already within the parent class. So what we can do here is simply execute the init method of the student class by writing student.init and passing in the first name, the last name, and the major. But for the additional parameter called home university, we need to write self.homeuniversity is equal to home university. So one thing that we can now do for the exchange student, which we cannot do for the normal student, is we can add a home university. So let me go ahead and add it to this instance of the exchange student over here by writing Oxford University for the exchange student 1. And accessing this attribute works similar to as it did before. We can simply go ahead and write a print statement and write exchange student 1 dot home university, and you'll see that it displays Oxford University for the exchange student we've just created. So now that we've played around with the inheritance of attributes, let's take a look at how this works with methods. Let's, for example, give the student class a function that allows us to print the first name and the last name. So we're going to define the print name function, which takes as an argument only the instance itself, and it prints out the first name and the last name of the student. So if I now have an instance of the student object and go ahead and run the print name method on this student, you will see that it prints out the first name and the last name in the console. This will also work for the exchange student without any problems. So for example, if I write exchange student1.printName, you will also see that the printName function is available for the child class because the first name and last name of the exchange student that I've created are printed. One last thing that I want to mention is that instead of using the parent class name over here, we can use the method super. The super function returns a temporary object of the parent class and allows us to access its methods. So in this case, we can also remove the instance of the object, self, from the brackets over here. Now you'll see that when I run this, in the console output, the result remains exactly the same. This function becomes particularly useful if you have very large files where you might change the name of a parent class. Because in that case, if you use super, you don't have to change all the references to the parent class.